Oké. Even kijken, wie ben ik? Ik werk voor, I'm working for Hazecast. I'm a senior developer and I'm a solution architect, so I'm being sent to customers to help them out. I'm also the author of Pragmatic Guide to Hazecast, which will be released on a website for free. I have 13 years of Java experience, and my big love is everything related to concurrency control and distributed computing. Who in the room has used Hazecast before? Okay, good. I see lots of hands. So, what is Hazecast? Hazecast is the leading open source in-memory data and compute grid. And our main goal is to simplify the development of scalable and highly available systems. Why Hazecast? Hazecast is a 2.5 megabyte jar. There are no other dependencies. You don't need to install any software, so you don't need to install, for example, MySQL or whatever. It's just that jar. It's a library. It's not an application framework, so you have complete freedom on your application architecture. We do not impose any constraints on that. You can deploy Hazecast as a standalone application, or you could deploy it in your Tomcat or your WebLogic. So that's not really our concern. And the cool thing is you can scale at the application level and not at the database level. It's an Apache 2 license, so it's free to use. There are no limitations. You can make as many clusters as you want. The clusters can be as big as you want, and you can have as much data in your cluster as you want. We provide all kinds of data structures out of the box. For example, an atomic long, an ID generator, logs and conditions, and a lot more. We also provide transactional data structures like maps and queues and stacks. And if you're not happy with the ones we provide, you can even write your own. So, what can I do with Hazecast? Normally, if you have a traditional application, and you get more load, then how are you going to deal with that load? Of course, you can buy bigger hardware, so you're going to scale up. But eventually, you cannot scale up anymore, because the hardware is going to be that expensive that it's not worth the effort anymore. What you want to do is you want to be able to scale out, just add more resources, and you get more capacity. And what you also would like to do is, in case of a failure of a machine, your system should still be aligned, so you want to have high availability. This is a Raspberry Pi cluster we built for the Java 1 conference. There are 48 Raspberry Pi machines, and each Raspberry Pi has 512 megabytes of memory and 700 megahertz ARM processor, so it's quite slow. But because we combine them using Hazecast, you get a very big, you get a supercomputer. So you can store much more data or much more processing power on it than a single machine can provide. So when should I use Hazecast? Yeah, you can use it for messaging solutions, event processing, clustered scheduling, or geoprocessing, cluster management, HTTP session clustering. For example, if you have a bunch of Tomcat machines and you want to replicate the session so that if a Tomcat machine fails, the session will be highly available. You can also use it for caching. For example, if you have a database and the database is overloaded with requests, just store the data in Hazecast so that you can offload it to memory. There are a lot of companies using Hazecast. Financial organizations like JP Morgan, Morgan Stanley, HSBC, Deutsche Bank. You have big telcos like AT&T and Ericsson. Gaming companies, Ubisoft, Blue Byte. E-commerce, Apple and eBay. On Apple, we have in total 600 members running. There are 10 clusters of each 60 members. And it's, as far as I know, it's being used as part of the App Store. There are a lot of open source projects, so even if you're not using Hazecast directly, if you're using these projects, then you're already using Hazecast. WS2 Carbon, Mule ASB, Enterprise Service Bus, Vertex, an application framework, Apache Camel, integration patterns implementation, Apache Zero, security framework, OrionDB, a graph database, Alfresco, enterprise content management system, and of course Graph, an OSGI container. We are part of the NoSQL family, so there are different categories, like data grids, key value stores, document databases, column databases, graph databases. And we fall in the family data grid. So our direct competitors are Coherence, Infinispan, Gigaspaces, Terracotta. How often is Hazecast being used? In October 2013, we had 3 million individual startups coming from 48,000 unique IP addresses. So let's start with some code. Creating a Hazecast is very simple. Yeah, as you can see it here, it's just a single line of code. If you do not provide any configuration, then Hazecast will just use a default configuration. But of course, you can provide configuration. Yeah, you can configure your network settings. You can create all your data structures here, your maps and your queues. The cool thing is that you don't need to provide all these data structures up front. So if you do not, for example, provide the configuration for a new queue, Hazecast will just make use of a default configuration. You can also do programmatic configuration. The XML is quite static, so that can be a problem. Sometimes you want to have more dynamic configuration. For example, you get data from a database to build configuration. You can easily do that in Hazecast. You can even say, like, I have an XML template file where maybe 90% of my configuration already is done, but then maybe there are some missing parts. You just load the config file and then you modify the missing parts. So let me give you a very short demo. So what I'm going to do is I'm going to create 2 Hazecast instances, and we have a little test application for that, purely for demonstration purposes. Yeah, so that you can insert commands, but it's not what you're going to use in your products. Yeah, you have a normal Java library. So when I'm going to start up the first instance, and now the second instance, then you will see in the logging that they are going to recognize each other. So it takes a few seconds. Okay, here. So now I have a two-member cluster, and they now know about each other. And I'm going to make use of this test application throughout my presentation. I guess everybody has seen code like this before. Yeah, it's an ordinary map. Yeah, you do your puts and your gets. The question is, if this map is going to be accessed by multiple threads, then this is not going to work because a hash map is not thread safe. You can easily fix it, just change the type to a concurrent hash map, and now you have a thread safe data structure. But what if you have different threads from different JVMs that want to access this map? Well, the concurrent hash map, that's not possible because it's an in-memory data structure, so you cannot share it between JVMs. It can be fixed very easily. Just change it like this. Yeah, you create your Hazecast instance, and then you retrieve your map from that Hazecast instance. This map is a distributed data structure. So let me give you a very short demo. So in this test application, we have a predefined map called M. And what I'm going to do is I'm going to put a value in here. And if I go to the other member, and I do a get, then I see that the value is there. You can configure a lot of things on the map. You can, for example, set the time to live, so that all data automatically gets removed from the map. You can create indexes if you're going to use queries. There are a lot of settings. I think the map is the most complicated data structure we have because there are so many different needs for it, and you can tune it completely to your heart's content. Let's look a little bit of the technology behind it. Yeah, what we do is we chop the data up in partitions. By default, we use 271 partitions. And what we do is we determine the partition ID based on the hash of the key. Yeah, if you put a value in a hash map, the key is being used to determine the actual partition ID. So I had my partitions, and just for discussion's sake, assume we have 3 partitions. If I start my first member, then all these 3 partitions are going to be part of this member. If I'm now going to start 2 other members, then you will see that the partitions automatically are going to be moved among the other members. The cool thing is that Hazecast is highly available. So what it does, it will automatically make a backup of the partition on a different member. So in case of a failure, if member 3 fails, then all the data can be restored. By default, we have a single synchronous backup. That means that if you make a change on the map, the change will automatically be available on a different member. You can say, maybe I want to have more backups. You can say maybe 5 or 6 backups. You can also say, maybe I don't have any backup at all. Yeah, for caching, that's very convenient, because you keep data only once in memory. You could even say, like, now, well, maybe I accept that there's a small time window if the main machine goes down and there's a change and he has not pushed the change to the other machine, that I'm going to lose some data. Well, that can be done. Just make an asynchronous backup. So I'm going to give you a very short demo of how it works. The first thing I'm going to do, I'm going to kill my member. So now we are back to a single member cluster, and I'm going to clear my map, because there was some old data in it. Now I'm going to insert some dummy data. Yeah, so I just inserted 100 dummy items. If I'm going to start a second member, and when it joins the cluster, I'm going to ask it for its size. Ooh, that's not good. Ah, yes. Map.size is 100. So the items are available. But the nice thing, I can also ask how much data is actually available on this particular machine. So I ask local size. And you see 53. This means it must be 47 on the other machine. Yeah, as you can see, 47. The cool thing is, because data is being replicated, and if I'm going to kill this machine, so the machine is now killed, since the data is replicated on the first member is able to restore the data, and therefore if I ask map.size, you get back 100. So no data is being lost. So it's very easy with the Hazlecast data structures to scale up, even to scale back. You can just remove members. And it automatically provides high availability because there are backups. We also have an option to get data, for example, from a database. What we do is you have two interfaces, that's the map loader and the map store. With the map loader, if you configure a map to use a map loader, and the map gets a key, request, like get for this particular value, then the map loader is being asked, okay, you can load this key. And there you have, for example, your database code, like a select, and the data is coming from your database. But you could also make a file system storage or something else. And the same goes for the map store. The map store gives you the ability to push data back to your storage system. And the map store can also be configured like with a write through and a write behind. For the write through, it means that if you make a change to your data, it will automatically be pushed back to your database. If you have a write behind, it could be that there's a time window where the data has not yet been written. But the cool thing is that because there is a backup, asynchronous backup, so even if you use an asynchronous write to the database or write behind, and the primary fails before he wrote the data to the database, the backup partition will write the change to the database anyway. So as long as the primary and the backup as long as the backup is there, he will take over the work from the primary. So you can still have high availability with a write behind map store. We also provide a multi-map. Normally, if you have a key, you have a single value. The problem is sometimes you want to have a key with multiple values. In Java, you can do it very easily. Just make a collection out of that value, and you can just add items to it. The problem is, if you do that in a distributed environment, then maybe that value, that collection is 1,000 elements big. And you are adding an item on it from a different machine. So that the whole 1,000 items are going to be sent back to you to the calling machine. You add that item, and 1,001 elements go back over the line. So in total, 2,001 elements go over the line. So it's not very efficient. And apart from that, it can also be suffering from a lost update. You have two threads concurrently do the same thing. Yeah, well, it could be that you lose data. So we set up the multi-map. I'll give a short demo. So we have a predefined multi-map in here called MM. And I'm going to start the other member. Let me see. Yeah, so, is my first value. The second value. Yeah, as you can see, I just got my collection back. We also provide a blocking queue implementation. That's very convenient if you have a point-to-point problem. This is just a normal blocking queue. The blocking queue is just an in-memory data structure, so it's not distributed. You can make it distributed like this. Just get your blocking queue from Hazelcast. And so this queue will be shared between different JVMs. So a small demo. So we have predefined a queue in here called queue. And if I offer an item 1, and I do a queue.take, then you will see you get the item that has just been put on a queue. The cool thing is the queue is also a blocking data structure. So if you do a take without an item being available, they call it block. So if I'm going to offer item 2 here, you will see the queue completed, the take completed. We also have a topic. With the queue, you create a point-to-point solution. With the topic, you can create a publish-subscribe solution. Of course, you can use JMS for that, but often it's a little bit of a hassle, complex API, and you need to install software. If you're already making use of Hazelcast anyway, you can just make use of the topic, and the topic also is extremely fast. Creating a topic is very simple. You just get your topic from your Hazelcast instance. You can publish messages using the publish method, and you can subscribe to a topic using a message listener. So in this case, there's a very simple message listener where I print out the value. And the cool thing is that the value is just a POYO. You can just throw anything in there, and there's no restriction of the type of data you want to send. Hazelcast 3 also has, of course, a client implementation. In Hazelcast 2, we had 2 client solutions. It was the native client and the light member. They all had their strong and weak points. With Hazelcast 3, we integrated that in a single solution that only has strong points. The cool thing about the client is it knows about your structure of your data. So maybe you have 10 partitions, and your client knows that the information for a specific get is on partition 5. It will immediately go to the machine hosting partition 5. So there will not be a lot of traffic within the network. We also offer encryption. We already had encryption in place between the cluster members, but now you can also have encryption between the client and the cluster. Sometimes you have a call to your cluster, and you don't actually care where that call is going to end up, but you do want to have a little bit of control on it. Maybe you want to send it to the machine with the least amount of CPU usage or the most amount of free memory. So you could create a load balance policy. You can now inject a custom load balance policy within the client, so that you have fine-grained control how the request is being routed within your cluster. And of course, we have a C++ version, and we are currently working on a C# version, so that you can use Hazelcast within different platforms also. Creating a Hazelcast client is very simple. You just get your Hazelcast client, new Hazelcast client, and the thing you get back is an Hazelcast instance. So once you get back this Hazelcast instance, you don't really need to know that you were working with a client anyway. So that's quite nice. Hazelcast relies on, of course, on network communication. There are two parts for this communication. The first part is the discovery. So if new members are going to come up, how are they going to find other members within the cluster? The simplest way to do things, that's using multicast. Multicast, you do a broadcast message and you will find the members within your cluster. It's very nice for demos and local development, but in most production environments, not really an option. So that's why we also have TCP/IP-based clustering, and how it essentially works is that you have a set of well-known addresses. So as long as one of these well-known addresses is online, then you can form the cluster. And in most cases, you want to have at least 2 well-known addresses, so at least 2 well-known members, because if one member goes down and you only have one, then new members cannot join the cluster. So that's very dangerous. So you need to have more well-known addresses. We also have an Amazon clustering modem. What under the hood happens is we log into your Amazon console, we read out all the machines within your specific region. And these machines, we apply some filtering, you can apply some tags. And after filtering, we use these machines as the well-known member of your cluster. So under the hood, the Amazon clustering is just TCP-based clustering, but it's a different way to retrieve those well-known members. And the normal communication, so as soon as the discovery is being done, is just TCP-based communication. Okay. Some more advanced Hazelcast. One of the big questions we sometimes get, and it's a little bit of an unknown feature, is that you need to define, if you do not want to use the default for this particular data structure, you need to define your data structures up front. You need to say, for example, here I have map 1, which has a particular time to live. Map 2 also has a time to live. It's exactly the same as map 1. Maybe I do not know up front how many maps I'm going to make. So you have a problem here, because Hazelcast needs to know the types up front. We can easily fix that. You can use a wildcard configuration. Yeah, so in this case, the map name within the configuration is map wildcard, and it will match with map 1 and map 2. So this way you have a very flexible way of dynamically adding new data structures. We also have something new, it's called XML variables. It's not extremely exciting, but it's a shame it was not part of Hazelcast 2. In Hazelcast 2 you have an XML file, and often in production you have a little bit of different settings than in the development environment. And there was not a real other option than just to copy-paste the whole file, which is not very maintainable. So what we now do is you can have XML variables in there, you can provide a property file, and then you can use the same configuration, just with a different property file for different environments. If you store data within a map, then the data is being serialized, because if it goes over the line, it needs to be, it cannot be in object form, so we send it over the line. And when it's being stored on the partition, it's stored as the binary. Yeah, it's the byte array. That's the standard way to work. Yeah, if you do a get, and it's on a different machine, then the data already is available in the byte array form. So you don't need to serialize the object, get it over the line, and deserialize it. So the object is already available in the right form for a lot of basic operations. But sometimes you want to store the object not in the byte array form, but you want to store it in the object form. Yeah? So as soon as the object is being sent to a different machine, on the other side, you deserialize the object and it's being stored in a map. It can be done using the in-memory format. And it's extremely interesting if you are working with predicates. Predicates, you need to have the object structure anyway to, for example, you can say I have a predicate which selects all employees with an age above 25. And you need to have that object there. So if the object is already available in the object form, then queries are extremely fast because you do not need to deserialize the data. Another thing is the entry processor, but I will get back to that in the presentation. One of the new things in Hazelcast 3 is data locality. So if you look at this coder, yeah, I have a log here, and I have some kind of a counter, and I have some data in a map. Imagine that you want to use all this logic, all this data, within a single process. The problem is that in production you get something like this. So it could be that your sum log ends up at member 1, your sum counter ends up in member 2, and your sum person ends up in member 3. So if you have a piece of logic that needs to use all these data structures, you have a lot of remoting, so it's very inefficient. The fundamental problem was that in Hazelcast 2, the name of an object has two functions. One, of course, identification. Two is figuring out the actual partition where the object is going to be stored on. In Hazelcast 3, we split this behavior. So the full name is used as identification purpose, but if you add the @ sign, everything after the @ sign will be used as the partition key. So if I apply this, then here I use the partition key foo, and I have my log, sum log at foo, my sum counter at foo, and my sum person at foo. And because foo is now being used as a partition key, the lock, the counter, and the person, they all end up in the same partition, like this. So you can have very fine-grained control on where data structures are going to be stored. My experience is that this is the most fundamental step you need to make, most fundamental choice you need to get right when you design your application. Because if you do not get this right, then you will get a lot of unwanted remoting in your system. The cool thing is you can also add an object to an existing object so that it falls in the same partition. We have a method for that, get partition key. So for an existing object like C1, we can create a new object and say, okay, I want this object to fall in the same partition as C1. One of the things we totally redesigned in Hazelcast is the executor. You can execute tasks anywhere within the cluster. You can say, I want it to execute this task on a particular key owner. I will get back to that part. You can also say, I want to execute this task on a particular member. And it doesn't sound very interesting. But the cool thing is, if you want to balance load in a cluster and you want to control where data is going to be processed, then you can create your own load balancer, which figures out which member is the best target to send the request to. So you can use that information to route your request to the right machine. And we also have synchronization, of course, in place. We have an execution callback. With execution callback, you have your function which is being executed after a set of tasks have completed. And of course, you can reference to a task using a future. So I'm going to give you a short demo. The first thing I'm going to do is I'm going to kill one member in my cluster. Yeah, so now I have a single member cluster. And I have an executor in here. It's called E1 because E of executor and 1 of a single thread. And what I'm going to do is that I'm going to execute 16 tasks, the dummy task, which each take 1 second. So when I run this, it's not particularly slow because the tasks are being executed sequentially. In total, it will take me 16 seconds. What I want to do is I want to be able first to scale up. Scaling up is simple. Just add more threads and it will go faster. Yeah, so you have a different executor called E2. Yes. So since there are now 2 threads available, it will go twice as fast with an E1. But eventually my machine will be swamped with processing, so I cannot add new threads to it indefinitely. What you want to do is just add more hardware to your system and be able to scale out your processing. So let's do that. I'm going to start another member. Okay, now my second member joined the cluster. If I'm going to do the same task again, so I'm going to execute E2.simulate load. Because there are now 2 members in the cluster, and each member has a 2-threaded thread pool, I have 4 threads in total. So these 16 tasks of 1 second, 4 threads, therefore 4 seconds. Yeah, you can also see that the other member is now participating in the load. So you can use Hazelcast as a data grid. Yeah, you can store a lot of data in it, but you can also use it as a compute grid. So it's a very versatile distributed library. We provide different options of concurrency control. For example, we provide locks. The locks, they are distributed. So imagine the following situation. Yeah, so I just acquired a lock, and the lock is held by a different member. And now I die. If the Hazelcast would not detect that I died, then that lock would remain locked. So everybody is going to get that lock will deadlock. So that's not a good thing. So Hazelcast will detect if the lock owner is dead, and therefore it automatically releases the lock. But now imagine that I acquired that lock, but now the partition which owns that lock dies. The cool thing is, because the lock is a distributed data structure, there's a backup copy of it. So the backup copy will just be used to restore the lock And the log will just keep on living as if nothing happened, and I even won't notice it. We also have something new. It's called the transactional map get for update. If you know Oracle, then you know probably the select for update. Well, this is something similar. So as soon as you do a get, the record is being logged before you use it. And we have the map log, which I'm going to demonstrate. Hello? Okay. So I have my 2-node cluster. I have a map, which I'm going to clear because it contains some old data. I'm going to insert an item. Yeah, so I just inserted Peter. And what I want to do is I'm going to log key 1. So the key is now being logged. If I now do here a map.put1talib, yeah, so I'm going to override my value. Because the log is being held, the call will block. Until, of course, I'm going to do a log.unlock. Oops. Unlock 1. Now the log is released. And if I do a m.get 1, you'll see that the value has been updated. If you look at this code, there are a few things which are very important you need to understand if you're going to use Hazelcast. If you look at this code, the first thing I do is I say account, I get my account from my account map. The second thing I do is I increase the balance, and then I need to write it back. You need to write your value back if you're using Hazelcast. It's not like Hibernate, where your object is automatically tracked in a session, and at the end it's being written back. You need to put your data back in your data structure. The problem here is that the read and the write of the value is not an atomic operation. Yeah, so if a different thread would do exactly the same thing at the same moment, it could be that money gets lost or money gets created, which is good. We can easily fix that. Yeah, we can use the account, the map log to acquire the log before we're going to do something with it. Yeah, this is a very pessimistic approach. This works, it's fine. Only, it's not very performant because it could be that all the data is on a different machine. So in this case, there are 4 remote operations involved. So I want to try to fix it. Yeah, the first thing I'm going to do is I'm going to try to make an optimistic version. So here you have an optimistic increment. So I need to do it in a loop because it can fail, and therefore I need to retry. The second thing I do is I get my old account. I need to create a new account which is a copy of the old account, because if you use, for example, the normal concurrent hash map, then replacement is done based on the address of the object. But in a distributed environment, an address doesn't mean anything. So we need to verify the byte content. So therefore, we need to have a copy of the old account. So if you're going to call the replace method, that old object must still be there. And if it's there, you can replace it with a new one. So this is a lot better, because there are now 2 remote operations involved, the get and the replace. But it still isn't perfect. And I think the fundamental problem here is that I'm using Hazelcast in an old school way. Yeah, if you're using a database, then you have data in your database and you have processing somewhere else. What you want to do is you want to send your function to your data, and you do not want to send your data to your function. Because especially if you, maybe you have a complex piece of logic. Yeah, you have an employee, and the employee has maybe a lease car. So I have 2 pieces of data, and I want to fire that employee. Then I need to do a few select statements, and I need to do a few update statements. So it's very inefficient. If I send my data to the function, send my function to the data, it becomes a lot more better performing, because there's now only 1 remote call involved. So let's implement it like this. What I did, I created a runnable. Yeah, of course it needs to be serializable. I will get back to that. And when I run this runnable, then I just copy-pasted the optimistic approach. Yeah, it's not very exciting which approach is being taken, because these calls are all being executed locally. And I can execute the task using one of our methods of the executor service, execute on key owner. So now you can directly target a machine where the logic needs to be processed. So it's extremely efficient, especially if you take your partitioning schema, if you take care of it, and data is being partitioned correctly, like the employee in the lease car, you need to make sure they end up in the same partition. So if you send a task to that employee, his lease car and all his data needed for that process will be available there. So everything can be done locally. We also have something new. This is something from Hazelcast and Hazelcast 3. It's called the entry processor. I need to tell a little bit of the background. In Hazelcast, what we do is we have partitions, and each partition has a queue of operations. And each queue is executed by only one set at any given moment. So if you have an operation in your partition, then you know you have exclusive access to all data within that partition. In this case, what we do, we have the balance processor, and it ends up as an operation on the operation queue. So you know that the balance processor has exclusive access to that employee. So you do not need to lock. And the other cool thing is, I told about the in-memory format of the map. Yeah, so if the value is there in a byte array, and I call this method, first thing I need to do is I need to deserialize the object, get it as a value, I modify it, and then I need to serialize it again. So there's deserialize, change, serialize going on, which is still quite expensive. But if I store an object in object format, then instead of a deserialize and serialize, this method just gets reference to that object. So it's completely in memory without any form of serialization and deserialization going on. Only, of course, for backups, which you need to push to the other machine. And you can execute the entry processor using the execute on key on the map. So this makes sure that the entry processor is being sent to the correct machine and is being stored there within the operation queue. One of the coolest things of Hazelcast 3, and maybe one of the least known things, is the SPI. Yeah, we have a whole bunch of distributed data structures. We have logs and queues and maps. And these distributed data structures, they make use of a shared infrastructure. Yeah, these are lower level things like operations. The operations are being retried. There's stuff with partitioning going on. We pulled out this common infrastructure to the user space. So you'll now have the same API, we call it the SPI, the service provider interface, as we use internally to create our own distributed data structures. So I give you two examples. A little while ago, I made a proof of concept implementation of a distributed actors implementation. The actor is just an object living within a partition. If I send a message to that actor, then Hazelcast takes care of the routing and sending it to the right machine. The actor has a mailbox. The mailbox was a Hazelcast blocking queue, so I already have that one covered because it's highly available and scalable. And what I also did, the actor can have internal state, and I used a little bit of trickery to get an internal state back into a hash map, or to a Hazelcast map. And because the Hazelcast map is also distributed and highly available, the state of the actor is therefore highly available. And the cool thing is, if a petition, the owner of a petition with an actor in it fails, then a different owner will be assigned that petition, and he will automatically restore all data which was there. So your actor just float freely around within the cluster without knowing that he's just moving around. And the other project I made is a remote interfaces implementation. If you know RMI, then you just have an interface and you have remote method calls going on, and this is something similar. We have a very flexible serialization API. Normally you can make your object serializable, externalizable, that's fine. But it's not very performant. I will get back to that. We also have something which is called a portable. With a portable you can store your data in such a way that you can, for example, have a C++ or C# client, because in a portable you store all kinds of meta information. And we also have something called a stream serializer. And I think the stream serializer is the most interesting part, because what you can do with it, you can connect it to existing serialization APIs. And one of them is Cryo. A little while ago, I was sent to a customer, and they have a very big online web shop, and they could not keep all data, all their products in memory. So what we did is we create a different serializer for that particular product based on Cryo. This is how I did it. So I had an option in there to compress because we want to see how much the Cryo has an option to compress data even further. So I wanted to have that configurable. And you create your serialization configuration. You said, hey, I'm going to use, for this particular product class, I'm going to use that serializer. So you can override the serialization which you have defined in your class. You can say, okay, I don't care about that, just going to use, go use this. So here you see a few benchmarks. We received a whole bunch of serialized Java objects. These are the blue bars. Yeah, on average, they are between 10 and 20K big. When the green one is Cryo. So if I enable Cryo, you get a 60% reduction in size. You can keep a lot more data in memory. But if I enable compression, on average, you get an 80% size and reduction. That means you can keep 5 times the amount of data in memory than with normal Java serialization. A colleague of mine, he was playing around with lambda expressions. You have the lambda expression, you see that in the second line. The lambda expression generated, as far as I know, it's not serializable. But we use Cryo to override the serialization behavior for a runnable. And this way we could distribute a lambda expression. One of the things I'm really waiting for in Hazelcast 3.2, we hope it's going to be added in 3.2, is a MapReduce implementation. Currently, we do not have a good mechanism for data aggregation, and with the MapReduce in place, we can easily do that kind of stuff. So if you have very big data sets, then you can do aggregation without causing problems. Of course, Hazelcast needs to earn money. Yeah, we have a company behind it, so we have the community edition and the enterprise edition. The Hazelcast community edition is not crippleware. Yeah, so the jar you get for the Hazelcast cluster is exactly the same jar as it's being used in the enterprise. It's not limited in any way. We only provide some extra functionality. For example, we have the elastic memory. With elastic memory, you store data off heap. If you have very big JVMs, 16 gigabytes or more, then the pause time for the garbage collector can be very nasty. So we store the data in Hazelcast outside of the visibility of the garbage collector. You also have a security module, very fine-grained authentication and authorization, and of course the management center. The management center is very nice for system administrators because you can see inside of a cluster what's going on. You can see the members, the data structures, the throughput and the latency. So it's a very cool tool to have. The future. And one of the things we are looking at are topologies. Currently what we have is we have a partition table. Let me see. So we have a partition table. And in the partition table, we know that partition 25 is being stored on member 19. We only have one partition table. And what you would like to have is maybe you have machines with very big, a lot of memory, but little CPUs. Maybe you have machines with a lot of CPUs, but little memory. And you want to say, hey, I have a bunch of executors here. I want to execute them on these fast machines, but I have a bunch of hash maps, and I want to place them on a bunch of big memory machines. With topologies, you can do that kind of stuff. You can say, well, this map belongs to the beefy box machine, or this map belongs to the big memory machine. We are currently working on the hosted management center. The management center is a commercial product, but the hosted management center will be free. It will be running in Amazon, and you can make use for free of the management center. Dynamic creation of data structures. Currently, we need to define everything up front, but if you, for example, need to create a new map with a completely new configuration, that can currently not be done. So we are going to add features like that. And of course, we are going to do the map of maps. If you know Cassandra, it's a column database. In the beginning, I didn't understand it at all, and I thought it was a little bit stupid. But after a little while, I really understood what's going on. And I think with the map of map is an extremely powerful data structure. You can create all kinds of indexes on your key. So it's a very versatile data structure. And we are working on tiered storage. Currently, we store everything in memory, and you can, of course, create your map stores and your map loaders to offload it to the database. But with the tiered storage, you get storage to disk for free. So it's something we're working on. We are hiring. We got a $2.5 million capital injection 6 months ago, so we are scaling up our application. That's how I also joined. So if you want to work for an extremely cool company, very smart people, Hazelcast is the place to be. I work remote. 75% of my time I work from home. It's the best thing ever. And 25% from my time I'm on the road, for example, conferences. So it's a really cool company to work for. So some questions. Does anybody have questions? If you have a good question, you get a Hazelcast book. Yes?
When a node is shut down cleanly,
Yes.
how is the data redistributed? Because when the node is shut down, then you need to transfer all the data from that node to the other node, or the backup node needs then to replicate to another node to take up the backup? So how is it optimized?
Normally if a node dies, it just dies hard. And because there's a... Okay. How does Hazelcast deal with the replication of a dying member? I think that was the question.
Stop the member cleanly shut down because you need to upgrade or whatever.
You mean that a cluster is going to be step-for-step upgraded, a rollout that currently is not available. That's something we are working on. Yeah, you want to not shut down a whole cluster, just member by member you upgrade it. That currently is not available. We're working on it. So you get a book. You can get it here. Okay, question.
Is the network communication providing an extension point in the same way that serialization API is? And I'm thinking of maybe using ZeroMQ instead of plain TCP sockets for network communication.
Currently, that's not available. So can you use ZeroMQ, for example, for the network communication? Currently, that's not available. Of course, you can always, it's an open source project. If you think it's really important, we are extremely happy with quit pull requests. So if you want to implement that functionality, then you are more than welcome. So you can also get a Hazelcast book. Yes?
How would you approach searching? In a map data structure, do we need some other data type for that?
What you can do, for example, if you have a whole bunch of employees and you want to find all the employees with a certain age, so you can search using a predicate. It's an object where you can evaluate your data structure, and if you store that object in an object format, then your predicates are extremely cheap because all data is available in an object format anyway. So you can also get your Hazelcast book. Oh. Yes?
Synchronization immediately, or is there a lag in? So, for example, I have two members. The one puts an entry in a map, and the second one reads it just some milliseconds after.
That's a very good question. So the question is Hazelcast sequentially consistent? If you do a write, immediately after that write, do I see what has just been written? Yes. What happens is that the operations for a particular key are always routed to a single machine. So there will never be copies of data. Yeah, so if you did a write, the next command is being queued, so it will therefore read the data which just has been written. There's only an option in the map available called the local cache, and then you can have copies of data. Or the near cache, sorry, my bad. It's called the near cache, and then you can have copies of data, and then you can read still data. But otherwise, no. You could also get your book. Yes?
Does that mean that, for example, if you have two nodes, that means that your node, since it's replicated, will have 100% of the map? Does that mean that it will always go to the other node, even if you already have the data locally?
That's so. Do I always need to go to the master partition, or can I make use of the fact that maybe my backup partition already contains the data? That's your question. Normally, you always need to go to the master partition, but we have a special option which is called read backup, and then you are allowed, if you contain a backup, that you're going to read from a backup. So you can also get your book. Yes.
Do you have any experience running Hazelcast on slower or generally bad networks? And is it something you can optimize for, or should I really keep Hazelcast in the data center?
So the question is, how well is Hazelcast able to deal with bad networks? That's an issue. Because if the network is bad, then what can happen? If it's really bad, then members, they maybe start to think that they are separated from a cluster. you get a split brain because nobody knows that he's maybe the only one. So you get maybe multiple clusters, and later on, if these separate clusters rejoin to a single cluster, then you have merge problems. So a split brain problem is the worst thing you can have in your whole system. And also, if you have very bad network communication, system operations will slow down. So it will cause a lot of problems if you have a really bad network. The network needs to be good. Somebody else? Okay, there and that. Yes?
How did you deal with sending the function to the data when you have C#, C++, and Java?
That's a very good one. Currently, it's not implemented. With the red.
Did you already try to experience with the new Lambda and especially the streams and parallel streams that are coming into Java 8 and see how the parallel streams work with your map?
So your question is, have you already played with Lambda expressions and the new EO functionality? No, we have not. I played a little bit with the Lambda expressions, a colleague of mine as well, just to make cool t-shirts. But we have not done something very serious about it. We need to get started with it. So you also can get your book. Okay. So your question is how code is being shared? Okay, I think I understand your question. We do not have distributed class loading. So the coder for your logic needs to be available on all partitions in the cluster. We do not automatically exchange classes. Yes?
If your application is in the cloud and you're using Hazelcast, how does the pricing go up?
Okay, so if you're using Hazelcast in the cloud, what's the pricing model? Hazelcast itself is free, so if you're not making use of the enterprise features, then it doesn't cost you anything at all. As far as I know, we do not yet have a real model for cloud computing, a pricing model for cloud computing. We have a very flexible sales department, so I'm sure they can come up with a very good sales price. Because at the end, the more machines you have, the cheaper the contracts become, and we also understand that maybe you want to have temporary machines for peak loads and then scale back, so you don't want to have the full price for the peak load. So if you talk to our sales guy, I'm sure he can give you a nice quote. Okay, yes?
How does it work with the global transactions?
So your question is, how does it work with global transactions? In what sense? Okay, so can you use Hazelcast in combination with JTA? Yeah. Yes, you can, because our transactions are a two-phase commit anyway, because you need to implement them internally. I do not know if you already have an adapter for it, but it certainly can be used in an XA environment. Yes? A very good question. So your question is, can I do remote method calls? Yes. Well, currently Hazelcast doesn't have that functionality out of the box. That's one of the proof of concept I was working on. The remote interface. Then you can just invoke methods on remote objects, but it's extremely dangerous. It programs extremely simple, and if you do your unit testing, it probably will all run fine. The big danger is that you can run into a chatty application. Yeah, so maybe you have an employee object which you remoted, and I'm going to ask for its first name, last name, telephone number, email address. So I already have a whole bunch of remote calls going on. So you need to be extremely careful how chatty your application is going to be. But currently we do not have the functionality out of the box. I'll spend some time on getting my remote interface project up running again. Then you can do that kind of stuff. More questions?
What are the technology behind Hazelcast? I mean, libraries for networking and stuff is internal or some open source libraries?
Okay, so do we use other libraries? No, we have a zero library policy for the core. Yeah, of course, we have some extensions like Spring. Yeah, okay, then we need to compile with Spring, and therefore we have Spring dependency. But the core itself, if you get the core jar, then there's zero dependency. So we do not make use of different products. Yes, so we make use of the full standard Java API and not make use of any particular other products.
Do you apply garbage collection to the distributed data?
So do we have garbage collection for the distributed data? No. Yeah, we do not. We do not. How to call it, count references or something. So we don't have that in place. There are a few things you can do. If you store your map data in a map and you want to get rid of all data, for example, you can set a time to live. But if you do not have that option, then you need to take care of getting rid of your old data. Yes.
With the blocking queue example and with many consumers, how does the cluster decide which consumer gets the entry?
Okay, so your question is the blocking queue, does it provide fairness for consumers? It's a very good question, and I think it deserves a very good answer, but I cannot give you that answer. If you want, come to our booth. I can bring you in contact with Mehmet. He's our chief architect, and I'm sure he can answer this specific question. It's a very good question. Yes? Okay, does Hazlecast support, for example, one-to-one replication? We do. It's a very good question, but now you caught me because I do not know a lot about this particular piece. So I'll say the same to you. Come to our booth and I'll bring you in contact with our chief architect because he knows exactly how this part works. More questions? In the back. So in case of a split brain, can a minority be, how do you call it? Be okay, so in case of split brain, can a minority be stopped to deal with requests? To be very honest, the split brain functionality is something you can customize. So I'm sure if you plug in your own policies for that, you should be able to deal with it. Okay, are there more questions? Yes?
Do you have expiration listener on Hazlecast?
So the question is, do we have an expiration listener on Hazlecast? Yeah. Can you elaborate on that?
For example, if some item expired, I can trigger something in my...
Okay. So can you be notified when data is going to be, how you call it, kicked out? As far as I know, yes, you can. We already have functionality available so that you can say the maximum size of a map is, for example, 1000, and all data will automatically be moved out, and then you can hook into your, I believe you can hook into your map listeners, or otherwise you can hook into your map store. So as far as I know, yes, you are able to listen to this kind of event and take your actions. More questions?
If the main node and its backup fails,
yeah.
Does Hazlecast have a way to indicate the application that we have probably data loss, and then that the application can decide to shut down or whatever? Or?
So your question is, what happens if the master and the primary partition fail? I think there are events for that. It certainly is available in the logging. It's a very good question, but I do not know exactly how this part works. So again, go to our mailing list or come to our booth and we will find somebody that can answer your question. But you only get one book.
Already sort of selling them.
Are there more questions? Yes, yes, you. Yes. Yes.
And it can't go back in sync.
So the question is, how well are we able when one particular machine is suffering from a peak load? A very good question. Again, I cannot give you the answer to this because this goes beyond my knowledge. Mehmet is our chief architect, and he can give you a perfect answer to this question. But you get your book. Yes?
Is it possible to add new partitions on the fly and still have your data automatically correct?
So the question is, can you add new partitions on the fly? It's an extremely good question, but you only get one book. This is one fundamental problem. You need to define your number of partitions up front. You cannot dynamically change the number of partitions. So you need to know up front a partition size as an optimum. You should not make it too big because else moving data within the cluster becomes too slow. So you need to know up front roughly how many partitions there are because that determines the size of the partition. So you need to know a little bit up front to deal with that situation. You do not have dynamic repartitioning.
By partition, sorry, I mean an actual physical machine.
Okay, you can just add new machines to the cluster. It'll just be fine. It'll just take a share of the load.
The new machine will automatically get new partitions that you have to find your partition.
Yes, if a new machine joins the cluster, that's the question. Does it automatically receive partitions? Yes. Hazelcast will automatically say, okay, you are currently not doing a lot. Let's give you some partitions. Yeah. Yes. Okay, thank you very much.